Hello again. Tonight we're going to talk about essentially a kind of computer display or dedicated computer display that will show you, date and time and weather information and astronomy information. And I wanted one of these at home, and I actually have two places for them, so I actually built two of them. And we're going to get into the gory details of these info displays. So I enjoy having these displays at strategic places in the house. I've got one in the bedroom, one in the family room, and I want them to do new and different things. The display has to be large enough that I can just casually look at it when I'm, walking in the room, and I want it at the computer where I'm doing things, watching videos and such, and I want it to automatically sense light. So as it gets dark in the room, I want it to dim things down, but it's when it's bright in the room or there's sunshine outside, then it needs to be brighter, obviously. And I want it to be battery operated, but not be replaceable batteries. I want it to be a battery that's always charging. So what I want it to do is display date and time, obviously all the details of that, indoor information like temperature, etc., outdoor information, but I don't want to have to, replace a battery and a remote temperature sensor, things like that. I want to get the weather information from, a weather station. And then astronomy information, I want to know, like, what's up right now? What's the current phase of the moon? That kind of stuff. I want it to be convenient. I don't want any touch screens or menus or those kinds of things. I just want it to have certain content, always presented, always automatically updated. I don't want it to be a real computer from the perspective of, I don't want it to have a keyboard and a mouse and such. I don't want to have to log into it or wake it up if I want to see it. I don't want it to have like a screensaver. And kind of like, wall mounted at a convenient place, which is probably why wall mounted clocks are so popular, because they're just there. They tell you the time and you just look at them. So my current info displays, and you've probably seen them, they're jokingly referred to as atomic clocks. They're not atomic. There's nothing radioactive in them. What they do is they listen to WWV in Fort Collins, Colorado. That's a radio station that the U.S. government, the National Institutes of Science and Technology, puts out there that will tell you time of day. It'll make pinging sounds so you have an accurate hack for 1 second. If you listen to the particular radio frequency, you can make the clock automatically adjust itself, except for daylight saving time, because it doesn't know where you're at. It has no GPS receiver. So they put a switch on it that's DST on or off, which means twice a year you're back behind the display, taking it off the wall, flipping the switch. It's just inconvenient. Your laptop computer and your mobile phone automatically know where you're at and change daylight savings time accordingly. The inexpensive atomic clocks have inexpensive, cheap LCD displays, monochrome, not color, and they get burned in. After a while, they start to get darker. It almost looks like the LCD general feel, not the actual letters and digits and stuff, but the general feel where the display is, starts to get what looks like a melted appearance, burn in. And that happens over time with inexpensive LCD panels. So I want something that won't burn in. It's more like LED backlit instead of LCD. So I want to be able to read this thing in dim light or at night, and I want it to automatically switch its color and brightness in case I wake up in the middle of the night and want to know what time it is. Not going to blind me. It's not like blue bright. It's maybe very dim red. And I want it to automatically update the date and time. So instead of it running on replaceable or rechargeable batteries, mine runs on mains power or AC. And what that does is the AC charges a mobile phone battery, like the kind of battery you'd use to boost your mobile phone when it starts to run low, and then you recharge that battery. Well, if you buy the right brand model of those kinds of lithium-ion batteries, they can always be hooked up to the AC power, and they won't go to a short life or burn out or burn up or explode or whatever. You can draw power from them while you're charging them. So you have to pick the right kind. They will run this display and the associated computer for hours. So if the mains power goes out for a while, if it's like a brownout or a blink or something, the display will keep trucking, no problem. And I wanted it to be an external display. So I didn't want the computer to be like hardwired to the display. And I want to be able to say, well, the display has to be of a certain size, HDMI type of display. So I found $50. You could get a 1920 by 1200, which is a little larger than regular HD, which is 1920 by 1080. Fine. It has a HDMI and USB-C, and it has speakers. I'm not using the speakers at the moment, but has all the normal stuff. So it's a big display, relatively big. It's not like TV big, but it's a relatively big display, higher contrast than your typical cheap LCD. And given that I put a computer on it, a little Raspberry Pi, I can program it. So I wrote a Raspberry Pi Python script that will go out and get all the data, format it all, and then pop it up on the display. And I can run it off of a wired LAN connection or a Wi-Fi connection. It'll automatically go out to the internet and get automatically adjusted time of day, including I give it my latitude and longitude, and it automatically knows how to do daylight saving time. I added a sensor for brightness so we can actually tell when the room is daylight lit up or the room is dark, like I'm watching a movie or something, and adjust the color and brightness accordingly. And then I can display whatever information I want. So I added another sensor that would provide me with the indoor ambient information like humidity, temperature, barometric pressure. Since it's internet connected, I can go out and get internet-based weather forecasts. I get the weather from the weather station at the Fort Lauderdale Executive Airport, or FXE, which is its acronym. And I want astronomy data, so there's a Python library I can call that will get astronomy data, so I can tell, what's up right now, what the moon phase is, that kind of things. So here's an example of light and dark. So the one on the left is the display with its data. And if you see there's reflective glare on it, that's real. These are real pictures. This is not like computer synthesized. This is really from the displays from earlier this week. And you can see the time, and you can see the date, and you can see current temperature, barometric pressure, relative humidity, which airport I'm getting the data from, the temperature at that airport, the wind direction and wind speed, the probability of rain in the forecast, the dew point, how muggy is it, and then the heat index, how hot does it feel like it is, and then at the weather station, what the humidity is. And then you see down at the bottom, looks like a bunch of gobbledygook, but the sun, at the time that I had this, the sun was up. It was in the western part of the sky at an elevation of 29 degrees. The moon was at first quarter and it was down. The moon was already set. ME is Mercury. So Mercury was in the western sky at 17 degrees elevation. Venus was down. Mars was in the south-southwest at 56 degrees. Jupiter was in the west-northwest at 2 degrees. And Saturn was down. And you can see same sort of data. A few seconds separated it because I took the black and white picture and then the color picture. No, the pictures were both color. The display was black and white or color. So this is a dark red. The mobile phone actually makes it look brighter than it is. It's really a dull red. So even though the time of day is synchronized to within about 100 milliseconds or 100 thousandths of a second, the software overhead for gathering all this data and putting it up on the display takes a couple of seconds. So between 2 and 4 seconds is how often the clock ticks off. So the clock doesn't tick off exactly at 1 second. It did when I first started working on it, but then I added bells and whistles, and now it's a couple of seconds. But it's accurate to a small fraction of a second. I'm fine with that. So why do this now? Well, first of all, my old static displays are getting old. The LCDs are burnt in. I said, well, what can I do with what technology exists today? All those cars with small HDMI displays in them, hey, that means that I can go buy one of those kind of displays for $50 and then use that as my display. And it operates on 5 volts. I don't need AC power to run the display. And I can buy a low-cost Raspberry Pi computer. I actually took 2 of my older, cheaper, slower Raspberry Pi Zero, W stands for Wi-Fi. I took 2 of those. They're the size of a piece of chewing gum. But I used the older ones. They were about $15 when I bought them. The later ones that have quad-core processors that run at a slightly faster speed, the Raspberry Pi Zero 2Ws, they're about $25. Still a reasonable price if you're going to be cooking one of these things up. And they can connect up via Wi-Fi, or you put a USB dongle on there and you can plug in wired Ethernet. keyboard, mouse, that kind of stuff. The software is for free to allow it to pick up network time protocol, NTP. And then you can get weather from the US National Weather Service. And then you can get these cheap little modules that allow you to pick up data signals from temperature and pressure and humidity and such. And then another sensor you pick up, and you wire these over the I2C interface to the computer. And now you can have indoor weather and brightness. So brightness, you can write the software that will trigger it to do light and dark. I described the computer. I run it off of a battery pack, programmed it for time of day, put in these sensors for indoor weather and brightness, and it's all powered by one of these phone bank battery that I run 100 all the time on AC power. So it's constantly being charged up. So if the power ever fails, it'll run on battery for several hours. And then when the power comes back on, it'll automatically charge itself. And once the power gets up to a level where it can power the computer will automatically reboot, reload everything. Great. And if you've ever had a computer that tries to keep time of day when the power goes out, they have a clock battery. That's the little like coin battery in them. This thing has no coin battery. So where do I get all the data from? Well, date and time I get from the US National Institutes of Science and Technology, network time protocol. I synchronize that. I give it my latitude and longitude, which I know, and that does the automatic daylight savings time switch. I can hook these things up with just an AC power cord, which is really not AC. It's you put one of those little wall warts that converts AC power to USB 5 volts, and then you run a little thin 5-volt USB cable to power it all. It's a very unobtrusive cable. You can buy them whatever length you want. You can buy, if you've got a white wall, you can buy it white to match the white wall. If you've got a brown wall, you can buy them in brown or black or whatever. So make them unobtrusive. If I want to know if the internet's up, I can ping google.com every 30 seconds, or I can just check the network time protocol. It'll tell me the last time it's had an update of status. I pull the weather from the local airport. I can tell whether or not I've successfully pulled the weather, so I know if the connection's running. I have my weather sensor and my brightness sensor, and I check those periodically and post the information. And when I pick up the room brightness, I can automatically switch from bright and dark. And a third option is if I can detect when I'm on battery, I can make it an even dimmer display to make the battery last longer. And then the astronomy information, I can use a Python library for pulling that. I've also considered one of the interesting things, if you're an amateur astronomer, is when is the International Space Station going overhead? And there's routines you can call that will tell you when the ISS is overhead. So I'm thinking of adding that in the future. So now I'm just going to flip through these slides pretty quickly, but I'll leave it up there where you can look at it for a little while. How to set up the Raspberry Pi so the Wi-Fi works. If you're new to Raspberry Pis, it's not rocket science or brain surgery. It's Linux operating system based stuff, and you got to know how a Raspberry Pi works. How to set up your Wi-Fi. So wall mounting, you've got this display and it's got information on it. What's a convenient place to put it? Well, on the wall. But I wanted a wall mount that I could tilt and adjust. So if it's up high on the wall and I'm laying in the bed, I can have the display tilted down where it's easier to read. I didn't have to stand up to go look at the display. So it's called a VESA mount. It's international standard for the hole patterns. It's actually what is known as an FDMI, a flat display mounting interface device. I bought a couple of those so I can mount them on the wall and tilt them. The particular type that I bought is inexpensive. When you get the mounting bracket up on the wall and then you want to take the display down because you want to do something with it, it's just one screw that you take out of the top and the display light comes off the hook. Convenient. So aesthetics. The battery pack that I chose really works well, but it's got a charging set of LEDs on it, and they're shaped like a little bear paw. So it's got little toes that make light when the battery is like less than full charge or full charge. They're blue. They're god-awful bright blue. So I'm going to have to put like red stick-on translucent film over those battery LEDs because it's creating a glow. I put all the electronics behind the display in the bedroom, and there's this like halo around the backside of the display to make it even darker. I'll just put some red stick-on tape that I've got over the battery. And like I mentioned, the power, cable aesthetics. It's battery powered, but it has an always charging USB cable going to it. You can order those to any length, different colors, stripe patterns. But if you really want it to run only on batteries, you can still use the mobile phone battery charger kind of thing, but you're going to have to trim the power down. Otherwise, you're going to be replacing battery or recharging it often. So the cabling, this is how it all interconnects. So on the top left, you see the AC power adapter. This little wall wart you plug in the wall. Out comes a USB cable, goes to the battery pack. The battery pack has two power feeds off of it, one to run the Raspberry Pi computer, one to run the display. The sensors, the air, the weather, indoor weather and light sensor, those are actually powered by the Raspberry Pi. So that's how it all hooks together. And if you want it pictorially, I just have a top of the printed circuit board. The entire Raspberry Pi is much longer than that, but I just have the parts you need to know. All the signals, if you want to know where the wires go and what the signals do, there's that information. You can see what the two sensors look like. The sensors are not huge. They're a little bit bigger than thumb size. And then how they connect up, how to use the I2C interface on a Raspberry Pi and what station addresses they show up as. And then network time protocol. The default configuration is fine. You don't have to do a lot of fancy stuff there. And because I'm going to be displaying text on the HDMI display, I need to be able to put the kind of font that I want on the display at the size and the color that I want. So I had to install a type of font that's scalable. And then how to get all the stuff updated on the computer to run Python and interface to the frame buffer, the video display. And then I said, well, I don't want to have to have a micro SD card that I put into the Raspberry Pi computer and then walk that over to my Windows machine to do updates and archive things. So I configured on the Raspberry Pi this thing called Samba. If you've ever used NetBIOS on a Windows machine, this gives you the ability to make another computer's shared storage look like just another folder on your Windows computer. So I installed Samba on the two displays Raspberry Pi computers, and now I can transfer files between them. So I do all of my development on one of the displays, and then I can back up all the stuff to its shared folder, and then go over to Windows and copy it and back it up and transfer it to the other display. And so I'm not like bucket brigading little SD cards around. And then the libraries for how I talk to the sensors. There's one for the weather sensor. That's a Bosch BME 280 is the weather sensor. They make 380s and things like that, but I just needed an older model 280, which makes it cheaper. And then the particular light sensor that I use is a TSL 2591, just rolls trippingly off the tongue. And then the basics of how you go about reading the sensors. How do I get light from this thing? And then I've got a number that says what the light is. Now, what do I do with it? Well, I set a threshold of 9. So when the number comes in, if it's 9 or less, then that tells me light and dark. So if it's less than 9, then that must mean dark. So I can adjust the color and things like that. If it's greater than that, I can say, oh, it's daylight and make it brighter. Weather. How do I read the weather? I call the library routine. It gets me the temperature as Celsius. And that's how you then convert it to Fahrenheit. Humidity. You get the humidity as hectopascals. That's hundreds of pascals. And then you can convert that to inches of mercury for Americans. And then you have the altitude. You can actually use the barometric pressure to convert that to an altitude in meters. And then you can convert the meters to feet. In case you want to use these kinds of sensors for other projects, this is how you do that kind of stuff. How do I get the astronomical information? There's a Python library called Skyfield, and then you install it. That's what the pip stuff is. You install that on the computer, and then you load that in your Python script. And then you establish a time scale because everything's moving in space. You've got to have not just what time is it, but basically a dynamic form of time. Time marches on, things keep moving. So you establish a time scale, and then the orbits of things. All the planets and moon such have orbits. Where are they right now? How fast are they moving? What's their tilt? What's their elongation? You establish the orbit or the ephemeris for it. And then where you are. Where are you? on Earth, but where are you on Earth? Because when you look up in the sky, different things will be visible based upon your location at different times of the day, different parts of the year. And then you can define your targets. Well, what things do you want to look at? Basic sun, moon, planets. Sorry, no Uranus, Neptune, and Pluto, because those are too faint and dim to be seen with the naked eye. And then you can calculate what direction, azimuth, compass, they're going to be, and then what elevation or altitude they're going to be above the sky, above the horizon. And then I said, well, azimuth, maybe not everybody understands, what is 180 degrees. Well, that's south, but that may not roll trippingly off the tongue for some. So I wrote a little routine that will convert azimuth in degrees to compass rose settings. So rather than saying it's at 180, don't you know where 180 is? It says south. And then moon phase, it just gives me a number. And then I convert the moon phase number into full moon, new moon, first quarter, last quarter. And that way I can then format all the stuff to the display. And then how to install the interface for the display and the graphics routines. Think about it for a moment. A display is nothing more than a bunch of pixels, and you can say what color you want the pixels to be, which also determines their brightness. But that's just one dot. How do I make letters and numbers? You have a font. Well, I want to draw number value that I have so it shows up in that font, that color, and is this big, what font size it is. And then I want to place that on the display at like an X, Y coordinate. So I need a graphical library routine called Pillow or Pill, and I use that to take the binary number, like a temperature, and then convert that into a string of text, and then convert the string of text into a graphical set of pixel values for color, the size of the font, and the brightness. And then all that gets written as pixels into the frame buffer for talking to the HDMI display. And as I learned early this morning, when one of my displays just stopped working, and then I went and looked at it, well, oh, my house temporarily lost access to the internet, and because I didn't have any error checking for what happens when you can't get to the internet, it blew up the Python script. The Python script errored off and said, hey, I've got a problem. I can't get to the internet. So I had to today go in and put some error checking in there and say, okay, do this, talk to this sensor, talk to the weather station. And if it fails, here's the default values. So if it goes to get stuff and it can't get stuff, it will have defaults and error handling for things like if it goes to get the temperature from the sensor and it can't, then it will make the temperature show 0.0. A clever way of saying, I think the temperature sensor has a problem. Or if it goes to get the weather from the local weather station and it can't, all the weather station related things will show up as 0 values, and compass directions will show up as like no text, empty string. So I had to put in error for that. And if I want to look at satellites like the International Space Station, and I lose access to getting these satellite tables updated, these are the two-line elements, the TLEs, then I need to have error handling for that. And it'll just use the prior cached, stale TLEs to give you a satellite position. It'll still be in the general area for about 3 days of accuracy, and then it'll slowly drift off of that because the Earth moves. And then if I lose access to the actual display, I can keep running the software and I'll just try it again next time. And of course, when you boot your Raspberry Pi, you want this app, this Python script to just automatically start up. And here's how I set it to automatically do that. That way, if it ever loses all power, then it'll automatically reboot the computer and it'll automatically restart the Python script, which means the display comes back up. This is the parts list. Now I've got an Excel spreadsheet, so if anybody wants the Excel spreadsheet, shoot me an email and I'll send you the spreadsheet. But these are the parts. Now, some of the parts you couldn't just buy onesie. You had to buy them a pack of them. So if I wanted to go buy like some connectors, I couldn't buy just one. I had to buy like 3 of them or 5 of them or whatever. That's why some of the prices are a little higher than you might think they should be. But the expensive thing was the actual HDMI display. That was $45.99, so $50. A lot of these things came from Amazon. you can see there in the seller name column, Amazon. So I provided links to the manufacturer that makes the device, and then the seller link, so you can click on the link, it'll take you to the Amazon site, and you can just buy it from Amazon. And if you're a Prime member, if you're paying out for that, for videos and other things, free shipping. Sometimes free 2-day shipping. So that was nice. So configurability. If somebody is seeing this video on the Broward Astronomy YouTube channel and they say, but I'm over in another part of the world and we don't do things with feet and miles per hour and Fahrenheit. We do things like the rest of the planet does in international standard units of measurement called metric. So I put in a command line option to say, okay, by default, the US, it will be running the US measurement units. And when you launch the Python script, you give it a -s or a minus SIUOM, it will change all the units of measure that come up on the display to standard or metric. And then you say, but I'm over in that part of the planet that uses 24 hours. I couldn't use -24 because the command line processing doesn't accept that, but it accepted a letter, and a lot of people refer to 24-hour time as military time. So -m or -mil hours. So by default, it'll give you 12 hours plus AM, PM, or you can run it up with -m. So you can select how you want it to run up. Easiest way to do this is just you go in and change the startup script so it has these options set the way you want. But if you really want to go in and display different things, I can send you the source of the Python script and change it to suit your needs. If you want to display things other than astronomical, it's on you to make the Python script changes and make it all fit on the display. The hardest thing was, I want more data, more data, more data. And then you find out you've only got so much room because you want to be able to put the display on the wall and then read it from 12 feet away with these eyes, with these glasses. So some of the things I wanted to see all the time had to be larger letters, which occupies more space on the display. This is a DIY or a do-it-yourself project. It's not a consumer commercial appliance. So I designed it as the major requirement is design it, implement it, test it, make sure it works, and then put it in there and forget it. No things to adjust, automatically updates, keeps the time of day accurate, automatically does daylight savings time based upon your location, your time zone. I didn't want to put any buttons or switches on it or touch screen. It's not that I don't understand the technology to do that. I have other things that do that, but this is just like a wall clock. It's there. You'll look at it. So here's an example of it operating in international standard units of measure and 24-hour mode. I did not swap the month and day because I'm using the letters for the month. So it's still discernible that it's Friday, August 8th. You can see all the units of measure are different, but the compass directions are still the same. So southwest is southwest anywhere on the planet. So if somebody really wants to do this, remember it's a do-it-yourselfer project. There's actually some soldering involved, depending upon what parts you buy. But if they really want to do it, shoot me an email, and I'm not going to send you any free parts, and I'm not going to physically help you put it together. But if you're really into it and you're really into working with single board computers and electronics and stuff, then I can provide that. If you want to just look at the parts, I can send you the Excel workbook. And if you want to buy it from different sources at different prices, or you want to go on eBay and get it, you don't mind waiting 6 weeks to 3 months to get the parts, you can buy it on eBay. I would say if I were to send you the Excel spreadsheet and you bought the parts and you had the Python script, start by launching it and just make it do what it naturally does. And then you can go in and change things, like you'll have to change your latitude and longitude because you probably live on a different place on the planet than I do. But that's pretty much it. And you can set from the command line what units of measure you want. But if you want to change the kinds of things being displayed or the kind of parts being used as the sensors, then yeah, that's going to require some Python programming capability. So in summary, I like my new displays. Given some basic single board computer stuff and some interfaces, it took me a long time to just get it to my perfectionist right way of doing things, test it all out under all kinds of circumstances. I'm a software engineer. I do things like that. But there are other people out there on the internet that have done do-it-yourself smart mirrors. They like having a mirror in the bathroom that they, when you touch the mirror, it will automatically show you the date, time, and current weather. So while you're shaving or doing your makeup, you can see what the weather is going to be like outside. I didn't want something that had a touch screen because I want to be able to read it from 20 feet away. And I don't really need more than two of them. One, if I only needed one, I'd still go buy one of those stupid displays that are static. But I wanted two of them. And by the time you add up two of them, now you're talking a price point where do-it-yourself gets to be reasonable. But it took me a while. It took me a couple of months to get it all together. It could be done even better. You could probably make it with a different kind of display that might be a little less expensive, maybe optimize some packaging or cabling. They do make different kinds of sensors nowadays that actually have connectors built in, so you don't have to solder wires. If you want to run it differently on a different kind of battery supply, you could do that. I would suggest keeping the actual frame buffer, the display, to be something that's separate. Don't get it all built in, because that way, if in the future you say, I like the content, but I want to put one in my radio ham shack, and I want a slightly larger display, or a 4K display. It's easy enough to just tweak a few things and keep the rest of it. So, and then of course I have links for all kinds of things. And then the software, and how you get things from the U.S. National Weather Service, and then how you get things that are astronomical in nature. And then there's the email address if you want to email. Okay. Comments? Questions?
Yeah. How much coffee do you drink?
I don't drink any coffee. I do the do.
You must have a different kind of day than we do.
Yes, I do. In fact, there's a sign on the front door to my house that basically says, don't wake me up. I'm asleep when you're awake. I'm awake when you're asleep. If you are trying to sell me something or proselytize for your favorite theist, then go elsewhere. If you want to contact me, you can reach me by mobile phone, text, email. Send me something, and when I'm awake, I'll respond, but you might be asleep. And sometimes I have to deal with that. Like, if I want to send a text message to Helen and I'm awake at like 3 o'clock in the morning, I can't do that because her mobile phone, when she gets a text from me, it's important. So her mobile phone will make outlandishly loud noises, and that'll wake her up. So I have to be sensitive as to when I send those things. When I'm sending emails to individuals, I need to know, oh yeah, that person has a normal lifestyle. So I'll adjust in the email what time to send it. I can do that in Microsoft Outlook. I can say, here's the email. I'm about to click on send, but first I'm going to go into the tags and say, don't send this before 9 a.m. I know it's 3 a.m. right now, but don't send this before 9 a.m. And it'll go in my outbox, and Outlook will not send it to the other person until 9 a.m. And I can set that. So yeah, my waking hours are noticeably different than most people. Essentially nocturnal. But think of it this way. When I'm at home inside my house working, my air conditioning is not struggling to keep the house cool. If I were awake in the middle of the afternoon, my air conditioning is normally set at 80 degrees because that's fine for me in the middle of the night. But in the daytime when I'm asleep, it can get to be like 82, 84 degrees now because the AC unit has to struggle because it's close to 100 degrees outside. So yeah, there's pluses and minuses. So I know this is way too much for our normal members, but I did it. I didn't want to keep it all to myself. So I'm going to put it out there as a public posted video on the Broward Astronomy YouTube channel. Like I said, I used a bunch of different kinds of parts in here. And if people want to know about certain things like, I don't know, glues, adhesives, cements, they can ask me and I'll respond with the information that I have. So if they want to know about, I've got like one of those little computers. How would I pick up like temperature and barometric pressure and humidity? I can tell you all about that. Or how do I make my computer automatically dim itself? Well, you got to have a sensor that will do that. But if you can read the sensor, then you can write a little something that will automatically dim the computer. But typically, you can go into a Windows computer and have it automatically do that if your computer has a light sensor. And the camera on your computer is actually a light sensor. So there's that. Okay, now proof is in the pudding, as the saying goes. So what I'm going to do now, and I'll have to, is I'm going to stop sharing. I'm going to switch cameras, and then I'm going to show you the actual display working. And there you go. See the numbers changing?
Yeah.
Okay. That's one of the two displays in my house. That's a live display. That's why you have glare off of it, because the camera is pointing at the display at a slight angle. But see how it's this kind of pinkish red? Because the place where it's at right now doesn't have much light. If I flip this switch, I've got a little spotlight that you can see the light come on, and it should theoretically, automatically switch over to, come on, there. See, it automatically switched to brighter. So when it's at night and I turn out the lights in my bedroom, it goes to that dim red. But in the daytime or when I have the lights on, it'll automatically switch to bright. And yes, I had to read the sensor, evaluate the value of brightness, and then say, below this it's dark, above this it's bright, and then change the font color to automatically map what I wanted. So I can turn the little light off. And theoretically, within a couple of cycles, it'll automatically go back. Now, did you see how when it went from white to red, the camera kind of bloomed and then came back down? That's because it's really dark and the camera is struggling to make it look bright enough. As the saying goes, the proof is in the pudding. There's my pudding.
Now, you said you created two things.
There's two of these. They're identical. This
Oh.
one is the one for the family room, and I have another one mounted on the wall across from my bed in the bedroom. So I have one of these in the bedroom, and I have one of these in the family room. And the one in the family room is going to go right above where my normal computer display is, and it's going to replace my aging fixed function LCD panel that looks like it's got melted ooze in all the display. But see, that way, if I get an itch and say, I don't want to display that value, I need a different value, I can go in there and change the Python script to display a different value. But you can see, right?
On the fourth line from the top on the left, it looks like it says FXE.
Yeah.
Yes.
I thought I saw it change from lower to uppercase and then back to lowercase.
You did. You shouldn't be pulling the weather data every few seconds from a website that has to serve like the entire US, because you're a burden. So what I do is when it first starts up, I'll pull the data from the weather station, and then I won't pull it again for another 60 seconds or another 60 iterations. So when it's fresh data, when it's like, I just pulled this, it's hot out of the oven, it'll be uppercase. And then for the times when it's just replaying cached data, it'll go to lowercase.
Aha. Clever.
When
Clever,
do you
though.
use this the most? During a hurricane?
No. I use this anytime I say, okay, what's the current phase of the moon? Well, it's full. If I went outside right now, and where's the moon in the sky? It's in the east-southeast at an altitude or elevation of 28 degrees.
That tells you that?
Right there, that next to the bottom line. Moon, full.
Oh, I can't read that last
28.
line. That's what I can't read.
Yeah.
Oh, okay. That makes sense. Okay,
Yeah.
thank you.
Okay, but you can see those bottom two lines are sun, moon, Mercury. Next, the bottommost line is Venus, Mars, Jupiter, and Saturn.
I don't know why, but I can't see it.
Let me
I can see it on my phone.
Let me flip it back to bright. And when it puts it on as light, it'll probably be easier to read. Give it a cycle. There. It's slightly out of focus because the camera's looking at it at an angle.
Okay, I see the moon,
Yes.
but I don't see Mercury.
Sure you do. ME.
Oh, I do see it. Oh, I'm embarrassed.
Well, I don't have that much space. If I want the letters to be large enough where
No,
these old eyes can read it from a distance, sun is SUN, moon is obviously moon because I didn't want it to say moo.
Well, if you had, I would have guessed ME was ME was
Yeah,
Mercury.
but there are three things on those two lines that start with M. There's the moon, there's Mercury, and there's Mars. So what's the minimum number of characters I need to distinguish those three things? And it's two letters. So I could do MO, ME, and MA.
Okay.
But I wanted moon to be obvious.
Well, you
Have
had
you
an
thought
word
about
for it though
changing?
too.
Have you thought about changing instead of saying moon full, just display a picture of a full moon or a half moon, quarter moon?
Okay. The particular font that I chose does not have astronomical icon characters in the font. If it did, absolutely I would do that. When I was just working in PowerPoint and kind of prototyping before I ever built any of the hardware, I did have that. I had the sun, a circle with a dot in the center. I had the moon, and I actually displayed the icon character for, is it full moon, first quarter, last quarter? I actually had the characters there. I also had another thing in there, which was the day number within the month, which was the center of the new moon, because astronomers like new moon. So I had new moon there, and I had to sacrifice it because it was too much data. It wouldn't all fit.
Too bad. Too bad. Sounded
So,
like that was a good idea.
yeah.
I didn't think of it, Diane. You did great thinking of it.
Yeah.
Thank you.
But remember, I do tell you when the moon is new. So it'll say moon new. And since the moon is going to be new for the better part of 3 days, or approximately new, the moon is new at a particular point in time during the month, but that could be any time during the day. But if you're awake and you say, I wonder if the moon's up, and is it a new moon tonight? It'll tell you that. It'll say moon new, and then if the moon is above the horizon, it'll do that. But if the moon's below the horizon, you know it's eventually going to be above the horizon. So it'll say moon full DWN for down. Now, why didn't I say set? So I could say rise and set. Because set is, it's an astronomical kind of thing. The moon and the sun don't actually rise and set. The earth turns. Think about it for a moment.
Yes, technically.
So when it's below the horizon, I didn't want to say below horizon. So I just said down or DWN. So yeah, there was a lot of false start of text and what made the most sense. Do you notice on the FXE line how the @ sign is an enormously large character?
Yeah.
Yes.
That's specific to this particular font. Now, I don't change the font size except at the text row level. So you can see how the top row is letters, and then it gets smaller and smaller and smaller. So each row has a font size. And when I pick the row for the weather, it's a fairly small font. But the particular font that I used, the @ sign is enormous. The only way I could make that @ sign smaller is to have sections of text, not just the whole line, but okay, if it has an @ sign in it, I need to break the text, switch the font to a smaller font size, and then switch the text back to a larger font size. And I'm lazy and that's too much like work.
Or use a slash instead of the at sign.
I could do that. I also tried, if you see the direction and altitude or elevation, it has a slash sign because I could have used an at for that. So I could have said east southeast at 29 degrees. You notice there's no degree symbol. The particular font doesn't have a degree symbol. So it's a fairly stripped down font. I wanted a font that could draw quickly. You'll notice it's not a serifed font. They're all straight
Yeah.
edge. A serif font would take longer to draw and would occupy more pixels. So it's a sans serif font.
What
So-
other text do you use for different phases of the moon? Like, how would you say waxing gibbous?
It doesn't get down to that level. It'll give you new first quarter, full, last quarter, and so new first
Gotcha.
quarter, full, last quarter. Yeah.
Okay.
Well, could you make the fonts smaller for the time and smaller for the date? And I just thought you just did that because you want to see them larger.
Yeah.
Yes, that's exactly the case because one of these displays is mounted high on the wall in my bedroom, about 12 feet away from where my head is in the bed. So I needed the time of day to be such that I could read it at night with my glasses off. So now you know how my vision is. I need font that big to be able to read it at night with my glasses off. So I said, well, I don't need to read the other stuff at night with my glasses off. So they're smaller.
I gathered that this would be very interesting to look at during a hurricane.
Well, given that there's recently been a 96-degree temperature outside, the heating, this is something weird. The HI in the like third up from the bottom, HI, the heat index, see how
Yeah.
it's 89F? It said 100F. And when it said 100F, the line went wider and the P on the left and the percent on the right went right to the edge of the display.
Ah.
I said, oh, okay. So that font size is good in case the heat index ever wants to be like 103. So yeah, there was a lot of madness to my methods. But I do appreciate the comments, and I won't say I haven't taken all of them into account, but the thing I really wanted to squeeze into there was whether or not the International Space Station was up and which direction and elevation should I look right now.
I find it interesting that you didn't include this in your presentation.
The live display,
Yeah.
Zoom would not allow me. I'm still recording right now.
Oh,
Zoom
you are
wouldn't allow
recording.
me.
I thought you stopped recording. Oh.
No, I
excuse me.
stopped sharing. I didn't stop recording. It's still recording.
Oh.
Yeah, but I can edit things.
Well, you mean there's certain things on this that you can't put on Zoom?
No. That it's not a Zoom customs restriction. It's if I'm sharing and I've got myself as a video overlay in the lower right-hand corner, I wanted to be able to just switch cameras. I can do that in Zoom. I can say switch cameras. And if I did that while I was sharing, it wouldn't switch the camera.
Oh.
So I had to get out of sharing, get out of like me overlaid on the background PowerPoint video in order to be able to show you the live display.
So I
Okay.
missed, why don't you have the ISS info on there?
Not at the moment. It's in the Python script, but A, I don't have it working to my satisfaction, and B, I'd have to squeeze some things around to get it to fit on there.
Or once a minute, maybe replace the bottom two lines with the ISS information and then go back to the planets.
Ah,
Yeah.
that's
Yes.
fine.
Toggle back and forth.
Yes, and it actually does that in order to make it run a little faster. So the indoor sensors for temperature, barometric pressure, humidity, those are every other cycle. So it goes through a cycle, gets certain data, and then it presents the data and writes it to the display. So indoor ambient stuff is every other cycle. And then the odd cycles, every 10 of them is go to the National Weather Service and get the weather data. So I don't burn their internet site. And then the astronomical stuff on the bottom 2 rows, those are every iteration because I'm giving you the elevation and the compass direction, and those change all the time.
Yeah. With the time, at least with my phone and internet connection, I'm not seeing every second. It goes like from 54 to 58.
Yes.
It's jumping
Same thing here.
seconds. Oh,
Same
okay.
thing
So
here.
the live version is the same. Okay.
Yeah, because it takes time to put all that crap on the display. So you see it go 8, 12. That's a 4 seconds. Because 15. Wait, that was only 3 seconds. That was only 3 seconds. It's because this is running a genuine Linux multitasking operating system.
Mm-hmm.
And it's running a single core processor. So when it wants to do things in the background, like network time protocol updates or just Raspberry Pi stuff that's just general running the operating system, it robs time from me. So I'm not running real time here. I'm running whatever cycles the operating system wants to make available to me. And then I do it and I grab the time and I display the time. So the time does not click by 1 second, but I don't need it to. I need it to be highly accurate, but I don't need it to click off every second. Internally, it's actually getting the time to 1/1000th of a second. That's what it's running internally. But the actual values it's getting is every couple of seconds. So initially I was displaying milliseconds. I was displaying 6 digits of milliseconds because I wanted to see how much time the actual loop was taking. And I wanted a high resolution evaluation. And when it got to be more than a second, I said, well, no more milliseconds. Okay. It's still using them internally. It's just not displaying them.
Yeah.
Okay. Any comments or questions before I stop recording?
Well, looks like a fun and useful project.
It took me a few months, but I like the end result, and I've already got the one hanging on my bedroom wall, and I've been using it the last couple of days. And this morning, I noticed it had stopped, and it was because my home internet bounced in the wee hours of this morning. And so when it bounced, it got an error in the Python script and just exited the Python script. So I had to put some error checking in there. So now if the internet's down, it'll use stale data until it comes back. If the sensors aren't reading, it'll show you zeros until it comes back. So it's got error containment.
Is there an indicator if it's using stale data?
Well, as you saw, the FXE is a capital FXE when it just pulled new data. And if it's a lowercase FXE, that's cached or stale data. But wind direction, if you get that every 30 or 60 seconds, that's fine. But the sensor data, I want to know if the sensors aren't working. I want to know if my home internet is down. So when those things happen, I actually replace the numerical values with zeros. So if all of a sudden the 79.6 degrees indoor temperature goes 0.0, okay, I know the temperature sensor's got a problem.
Or it's really cold in your house.
It's really cold in my house. But if it shows up as 0.0 occasionally and then goes back to automatically getting the temperature, I know it may be like a weak solder joint or a wiggly wire or something. If the FXE stuff all of a sudden starts showing up as 0 and dash at 0 miles per hour, it's like, okay, the internet's down. If all of a sudden all of the astronomical stuff starts showing up as the names of them are still there, but I get just like /0 for elevation, it's like, okay, so not up to date. The ephemeris, the planetary orbits and stuff, they don't change all that often. But if I was
Yeah.
to put up the International Space Station, the ISS's ephemeris, the two-line elements, the TLE files, those change about every 3 days. So if I was working off of a stale TLE for the ISS, you probably wouldn't know it for 2 or 3 days. But if I couldn't fetch it, I know how to check for the error for that, and I would do the same thing. There's a capital FXE. You just
Yeah, I thought.
um, I would do the same thing with ISS. So if the ISS was lowercase, I'm working off of cached data. If it just updated itself, I could make it say capital ISS and then go back to lowercase. So there's common ways for doing these things. And I never had to change colors on things because I'm already using color and brightness for light and dark. I didn't want to have like mixed metaphors and say, I want the moon to be full, but I want it to be like green, or the sun to be yellow. Well, now how do I make a bright yellow versus a dark yellow? Much easier. I'm a lazy programmer. Just all bright or all dim. And when it's dim, dim red.
How did you decide what screen size to use?
$50.
Okay.
I wanted the largest, highest resolution HDMI display I could find that was USB-C 5-volt powered. And I found the one for $49.93 or whatever, the $50. And that's it. And the actual size is, let me get my measuring instrument here. The diagonal measure is, I'll get the display area itself, is 16 inches, 15.9, but it's 16 inch. It's a 16-inch diagonal display. But the way I've written it is I could unplug this display and plug it into a 80-inch display. All the text would be ginormous, but I wouldn't have to change anything in the Python script because it automatically knows what size display you're working with.
If there's no wind, what does the direction say?
I don't know. I've not seen that. I've seen 3 miles per hour at Fort Lauderdale Executive. I'll have to be on the lookout. I don't know what the direction is. That's just a text string that I get from there. It may be like dash.
Oh, or still or something like that. Okay.
I don't know. I'll have to look out for that. But what I'm actually doing is I kind of robbed something from somebody else's example code. The National Weather Service website that displays this data actually displays it in tabular form. And I grabbed the HTML response from the website and I actually parse using the parsing routines available in Python and Linux. I parse looking for like, show me where temperature is, show me where heat index is, and then I go look at the column to the right of it to find the value, and then I can divert the value from a text string to a number. So that's why not only do I not grab the website every cycle because it would burden the website, I also don't grab it every cycle because it probably takes a good portion of a second to process all the values off the display. Hey, keeps me off the streets. Anything else? Okay.
What is your new project?
I've got a whole list of them. They're in the email that I send around.
There's also the old projects that have been pushed down on the stack.
Yeah, that's what I was wondering.
Yeah.
What is your next project? Not what you're, I know you have.
Oh, okay. Well, I
projects.
can tell you that I've been receiving parts for my outdoor radio astronomy antenna that is on a motorized altitude azimuth mount. And I've got maybe 90+% of the parts in already. And so I need, now that this is not going to be occupying my time. Well, this coming week, I'll be working with the the medical device community for all of those Google Meet appointments and the Google group adjustments. So that's a sink of my time this coming week. But the following week, I'll probably get serious about putting up the radio astronomy antenna. And I've got a box that will have controls on it. It's not going to be a computer interface to the antenna. It's going to be a fairly coarse interface. But that'll probably be the project that gets the bulk of my next efforts. I know you want to see the vacuum floaty aircraft.
Yes.
Yeah, and the power from vacuum energy. And yeah, I've got a number of them out there. But I still have parts, and usually it's because I'm waiting on a clever way to fabricate something, because they've got a lot of them to do. And then once I fabricate them, I have to find the right materials for gluing it all together where the glue doesn't weigh too much. Something like that. But yeah, I mean, you'll probably like this one because I have been working on the vacuum floaty thing, and lots of parts are going to fall off the top of the pile here in a moment. But okay. I got to switch cameras back.
It's cool. We can see you reflected in the screen.
Oh, yeah. And now you can see all the junk in my background.
Ah,
See this spidery looking thing?
Tinker Toys.
yeah, erectors.
I 3D printed this little white thing,
Uh-huh.
and it's hollow on the inside, so it makes it very light. These rods are actually carbon fiber. And the idea is I now need to make 18 of these little white things, but instead of them being flat, they need to be the corners of a three-dimensional shape. And making those on my 3D printer is something still in like fabrication mode. I need to figure out how to write the algorithm for making this thing, but bend it in 3 dimensions so I can make them. I've got 18 of these things, and I need to join them all together. But I drilled a hole through the center. You can see there's a hole drilled in the center of it. On the other side, there's this little gray thing. That is actually, if you get a medicine and it gets injected to you with a hypodermic needle, and you see the little medicine vial, that is the particular kind of rubber stopper that is airtight. So you can stick a needle through it and then pull it back, and the butylene rubber will seal it back up and make it airtight. So this is the way that I would evacuate the three-dimensional object.
And what is this three-dimensional object for?
If you were to make a three-dimensional object of a certain size, and the weight of the three-dimensional object with its covering to keep it airtight is less than the weight of the air that would occupy the inside of it, when you evacuate that three-dimensional object to around 50%, it doesn't have to be 100% vacuum, you evacuate it to 50% vacuum. If the weight of that 50% of air is less than the weight of the three-dimensional object, it should have negative buoyancy in air.
Right. Okay. Now we don't have anything that does that now?
No.
Okay.
Because it takes so much effort to figure out how to design it and make it the right size so that, the vacuum would be light enough that you don't want to have to do it at zero pressure, because that exerts a lot of external force and would collapse the three-dimensional object. So 50% vacuum, you can probably sustain that. And if you look kind of, that little grayish white thing in the background, that's actually a sphere that has a partial vacuum in it. How does it retain the spherical shape? It's because the plastic has a little bit of solidity to it, but it's still kind of pushing itself in. So that was one of the early attempts. And you can see the little colored sphere. I'm trying, which shoulder? This shoulder. You can see the little colored sphere there. That was my very first attempt. Let me reach back and grab that sucker.
Ah, there we go.
Ta-da! This was the first attempt. And you can see it's a little child's toy. It's just lightweight, rubbery plastic that the child can like bite into it or squish it or whatever. And let's see if I can find it here. Right there. It has a similar place where I can stick a needle valve in there and vacuum. I've got a 5-gallon vacuum tank and a 6-gallon per minute vacuum pump, so I can suck the air out of it. And when I went to suck the air out of it, it started leaking. So you can see that there's strips of cellophane tape. So I had to tape it all. And the actual plastic that's on the outside is a heat shrink plastic. So I put the plastic on the outside, I put the tap in, and then I started subtracting the air, and then I used a hot air blower to blow around the outside of it to like shrink the plastic. And it could take about 25% vacuum, not 50%. At 50%, it just crushed in on itself. But at 25% vacuum, there wasn't enough reduction in weight to make it lift up. I probably needed another 15, 20% towards zero vacuum to get it light enough, because the plastic is heavy. This plastic and carbon fiber is far lighter than this whole thing. The other thing is, see how much larger it is than this? If I make a 3D object this size, there's a lot more airspace inside of it to be evacuated at 50% to reduce the total weight of it. So that's another.
The favorite shape would be a sphere, I suppose.
No. You can't use a sphere because the sphere will collapse.
Oh.
And if you made the sphere hard plastic, now it weighs too much. So you have to make it out of a spoked design that has a heat shrink, like 1 mil thin, like stretchy plastic on the outside of it. So all of those factors have to come together, and then you have to fabricate it and assemble it. And by the time I assemble it, it'll be close to 1 cubic meter. It's a little 1 cubic meter. And you can actually go on the internet and say, how much does 1 cubic meter of air at sea level weigh? And then I can say 50% of that weight, I've got to make sure that my entire thing does not weigh more than that.
Now, is there anybody else working on this?
There are a lot of people on the internet working on it. Let's just say I'm the only one I found that is seriously working on it. There's a lot of people that have tried it, and the object just doesn't
it's
lift.
extremely trying until you find the right shape and everything. It's
got to be the right size for the right volume, and the entire structure has to be the right mass, and has to have the right structural integrity, so that when you reduce it to 50% vacuum, that it won't collapse in on itself. But once you get all those parameters in place, there's nothing in physics that says it won't rise.
How stiff are those? How stiff are those carbon fiber rods?
Well, now this is something that I found out after the fact. These carbon fiber rods are solid.
Oh, I was going to ask if they were hollow. Okay, yes.
They're solid. I could have, for more money, bought slightly larger diameter hollow ones. But then I measured the mass, the weight of the thinner solid ones versus the slightly larger diameter hollow ones, and the hollow ones weighed more.
interesting. Yeah.
So they're carbon fiber, so they're extremely stiff.
Yeah.
So once I make the bent 3D spider shape, and join them all together. And then I put the stretchy plastic on the outside and I heat shrink it, and it holds it all itself all together. And then I start pulling vacuum. I'm guessing that I can at least get a 25% reduction in air. And if the total weight is less than 25% of the air volume weight, it should lift up. Now, what is the physics principle by way this would work? How many of you have ever scuba dived? Have you ever inflated a floater? Take air from your buoyancy compensator, and you have a little rubber balloon, and then you have the rubber balloon on a string, and you pump some air into it, and you're down 40 feet, and this balloon blows up, and then you release the string, and it zooms to the surface.
Yeah.
Well, why is that?
Well,
It's not because you put hydrogen or helium in that. It's because the pressure of the medium that you were in is so much higher than the mass of the object containing the air. The air is going to be so much lighter. That's why it just goes like, it's going up. Why does it stop when it gets to the surface?
It's air.
Because the weight of the rubber balloon plus the weight of the air that you inflated it with is heavier than basically the surface tension of the water. So it rises to the lower density environment, air, and it stops. What if you had a thin balloon and you filled it with hydrogen? It would go up faster, and when it got to the surface, it would keep going. But what would happen to the balloon when it got to the surface? The balloon would expand.
Expand, yeah.
Doesn't the balloon expand? Doesn't the balloon expand all the way up?
Yes.
So, so it's both the buoyancy of the thing, and also the buoyancy is increasing of the total balloon. So why won't your device pop?
Oh, that's an interesting phenomenon. Because I started looking at helium and hydrogen filled balloons that loft things to like the edge of space. And why is it they always pop?
Mm-hmm.
Oh, they do pop?
Think of the balloon, think of the little air thing that you inflate underwater. The balloon itself is not thin, it's stretchy, rubbery. When it gets to the surface, it stops there because the outside pressure is such that it's not going to expand any further because air is lower pressure. But if I take a weather balloon and on at sea level, I fill it with helium or hydrogen, and then I release it, it wants to float to the thinner environment. So it's going to go up, and when it gets to the edge of the atmosphere, is it going to stop? Well, the balloon keeps expanding. At some point, the weather balloon is going to be stretched so much so that the actual molecules of the plastic get pulled apart. The moment the molecules get separated, the balloon rips itself apart. Think about that one. Think about that for a moment. All of the many thousands of weather balloons that we've sent up over the decades. Well, where is their helium and hydrogen? Well, their hydrogen went out into space. That just goes out into space. They have found out that, as you go through the troposphere and the stratosphere, there's another one up there called the mesosphere. The air pressure of the mesosphere is not zero, but it's enough that helium won't go any higher. It kind of like it gets to its level of buoyancy and it just stops there, just like the little rubber balloon stops at the surface of the water. The helium goes up to where it's at, and it forms a very, very thin layer. So all of the helium we've been exploding from balloons over the decades is forming this microscopic thin layer around the mesosphere of the Earth. Will we ever fill it up? No, because Earth be big and layer be very thin. But how do we know that for sure? Well, we send balloons up. No, the balloon will explode. The balloon will explode. And before you get to that thin layer, your payload's already coming down by a parachute. We send rockets up. Yes, you send sounding rockets up. How long does the rocket have to sense a layer of the mesosphere that may be a fraction of a millimeter thick? And it's impractical to sense it. Well, how do you know that there's helium there? I have no assurance. I have only physics.
Can't call it the heliosphere, though.
No, the heliosphere is something different.
I know.
That's the sun.
I know.
But if I do get something to lift up, it is only going to grow so large because it's not having hydrogen or helium to put outward pressure on it, much like the balloon that comes up to the surface of the water and then doesn't go any higher. When a vacuum-filled container has negative buoyancy and lifts up, it's going to stop where it no longer has negative buoyancy. And where is that? That's where the air molecules are too thin. It's like there's too little air and it just stops. So it's all about, if I can build it and the weight is right and the vacuum is right, I just let it go. And it just slowly rises up. And the more negative weight, the more negative buoyancy I have, the faster it will rise. If I can get it to like 80%, it's not going to shoot up like a rocket, but it's going to shoot up so fast with enough force that I need to keep a string on it. Otherwise, we're just like, gone, bye.
Put a return address on it.
Well, according to the U.S. Federal Aviation Administration, I'm required to do that anyway. How much does the label weigh? That's a factor I have to take into account, because you remember that little butyl rubber thing that I used to insert the needle so I can evacuate it?
Mhm.
That's actually heavy compared to the rest of the structure. It's the heaviest part of the structure. So if I release it, it's going to orient itself with the rubber stopper down.
Mm.
So that's where I need to put the label. Now, should I put a label on it, or should I spray stencil on it, the lettering?
Etch it into the rubber.
And then you have to get lightweight
No.
ink too.
Yes, I have to get lightweight ink. What could I do?
You can't etch the rubber?
No,
A tiny QR code.
I could put a tiny print on the actual 3D printed PLA plastic. I could 3D print around the circle. So yeah, there's solutions for problems, but right now, let's just say my 3D math is, I'm going to have to go back and read some stuff that I read back in high school. It's not just Euclidean trigonometry. And I got to get to 3D printer to do it. And when you're printing 3D PLA, it's going to be a kind of bent surface. Which side is down? Which side sits on the base of the printer? And then I print up from there. When I print up from there, that means every layer of the individual little fingers of the spikes is going to be something that could be like pulled apart, because it's 3D printing. So I have to orient the 3D part kind of at a 90-degree angle so that it prints the layers this way, not around the fingers. Things like that. I'll put that over here in the corner until my brain fart in the middle of the night. So, Eureka! And then I'll get back to work on it. Okay. Anything else before I stop recording? Hearing nothing.